So guys, Math 2 is about differentiation. All the formulas that you use in Math 1 remain the same. So it will be useful for us to start by recalling all the formulas that you've seen in Math 1. Okay, as I said, we will start by recalling all the derivatives that you've seen in Math 1. First of all, we have derivative of a constant. D over dx of k, it's always equal to 0. Example, derivative of 2 will be equal to 0. So all the numbers from 1 to 1 million, it will always be equal to 0. Secondly, we have the chain rule. So when you are given f of x to the power n, so this is a general formula, okay? The answer is you take the n down, okay? You derive f of x, okay? Then you multiply by f of x to the power n minus 1. For example, let's illustrate this by an example, okay? Let's say you are given x to the power 5. So you have to derive this one. It's going to give you 5. You derive x, then you multiply by x to the power 5 minus 1. And finally the answer will be 5x to the power 4. Why is it 5x to the power 4? Because the derivative of x, it will always be equal to 1. Okay, second example. You may also be given, let's say, x squared minus 1 to the power 3. You do the same thing as the first example. You take the 3 down, then you take that function x squared minus 1, you derive it, then you take it back again to the power 3 minus 1. Okay. Then here you have to derive this function. It's going to give you 2x. So 3 times 2x times that one, x squared minus 1 to the power 2. 3 minus 1 is 2. Then finally your answer will be 6x times x squared minus 1 to the power 2. Okay, so guys, remember, how did I find the 2x? It's because we took the 2, we bring it down. That's what it gave us 2x. Then remember the derivative of a constant. This minus 1 is a constant. Derivative of all constants, it will always be 0. Then 2x minus 0, we have 2x. That's where the 2x came from. Okay guys, now we have product rule. I hope you all know about product rule. So when we are given two functions, f of x times g of x, and they ask you to derive this, it's going to be f of x times g of x, you derive g of x, then plus f of x, you derive of f of x times g of x. For an example, you have x to the power 3 plus 2, okay, times x to the power 5 minus 3. This is just an example. So how are you going to do it? So we're going to apply this formula here, okay? So we keep this x squared plus 1 as it is. Then we derive the second one. It's going to give us 1 because x minus 1, we derive x, then we derive 1. When we derive x, it's 1 and 1 is 0. So we keep 1. Plus, we derive now the first one, the first function. It's going to give us 2x, okay? Because the 2 will come down, then and then it's going to multiply x. Then when we derive 1, it's going to give us 0. So we keep the 2x. And then we take the x minus 1 as it is. Then this is going to give us x squared plus 1, then plus 2x squared. 2x we multiply by x, we're doing the distribution, okay? Then 2x multiplied by minus 1 is going to give us minus 2x, okay? Then x squared plus 2x squared is 3x squared. Then we take the minus 2x, then finally plus 1. So this is how we do it. Okay guys, now let's talk about quotient rule. We still have f of x over g of x, okay? We are recalling all the formulas you know already, okay? So here it's going to give us f of x. You derive it, then you multiply by g of x minus f of x. You don't derive, then you derive only here g of x, okay? Over g of x squared. Let's now illustrate it by an example. Let's illustrate it by an example. When we are given x plus 2 over x minus 3. So you do the same thing as it is there. It's going to give you x plus 2. You derive times the g of x, which is x minus 3, then minus x plus 2. You don't derive f of x, and you derive this side only x minus 3 over x minus 3 squared. Okay. Then you already know how to do all this because we've explained everything. So this is going to give you 1 and then x minus 3. And the other side is going to give you x plus 2. That other part is 1 already. Everybody can see it. Over x minus 3 to the power 2. So now you have to develop only this. So x minus 3 minus x, then minus 2. Don't forget, most of people forget about this. When you take out the brackets, you have to multiply the minus with all the sign inside. So all the sign is going to change, okay? So all the plus become positive, negative, and all the negative become the positive because there is a minus 1 in front there. Over x minus 3 to the power 2. Then finally, the x we cancel each other, and minus 3 minus 2 is minus 5. Then over x minus 3 to the power 2. So this is your answer. Okay guys, let's now talk about the derivative of an exponential, okay? So when you are given e to the power f of x, what you need to do, you take down the f of x and you derive it. Then you multiply it by e to the power f of x again. Normally we add a ln of e, but you don't put it because ln of e it's already 1. So guys, the reason why I insert this ln of e, because you have to know that there is a ln of e that people don't put it, okay, because it's 1. So it's a special case. Ln of e will always be equal to 1. In some books they can write it as log of e base e. Okay, so when we see this, it's 1 already. Okay guys, so now we're going to illustrate this formula by an example. Let's say you are given x to the power, e to the power x plus 1. And you have to differentiate this. You take the x plus 1 down, you derive, multiply by x, e to the power x plus 1, so then this is going to give you 1 multiplied by e to the power x plus 1. So your final answer is e to the power x plus 1. Okay. So guys, remember we gave you e to the power f of x. There is also a to the power f of x. Okay, so this the base here is a. So this is a constant, can be 2, 3, 4. Okay, it's a special case. Now here, the derivative of this one is going to be, we're still going to write the same thing as it is there, but something will change because there is a there. So here we derive f of x, then we multiply a to the power f of x multiplied by ln of a. This is why I even showed you here why we don't put the ln of e. It's because it's 1 already. But here ln of a can be 2, 3, so we have to keep it there. Okay. Now we're going to illustrate all of this by an example. Let's say you have 2 to the power x. Okay. And they ask you to differentiate this. So we're going to take the x down, you derive it, then 2 to the power x, and finally ln of 2. Then this will give you 2 to the power x multiplied by ln of 2. Okay guys, let's now talk about the derivative of a logarithm. I guess everybody knows what logarithm is. So this is the symbol, okay? So let's say you are given log of f of x. If there is nothing here in the base, it means that it's 10 for a logarithm, okay? But you don't usually put it. But now, if we have to differentiate this, let's say the base here is n, it's not known, okay? So this is going to give you take f of x, you derive it, okay? Over f of x again, and multiply by ln of that's n. Okay, let's just change it. Let's put a. Multiply by ln of a. So this is the formula. Okay, guys, let's now illustrate this formula by an example. Log of x squared plus 1 base 2. So you just look at the formula as it is and you replace. So you take x squared plus 1, you derive over x squared plus 1 multiplied by now ln of a. A is what is 2 in this case here. And then you do all the tricks, you know. 2x over x squared plus 1 times ln of 2. Apart from the log that you just seen now, there is also what we call ln. Okay, so when you are given ln of a function, so they want you to differentiate this. It's going to give you f of x you derive over f of x, and you're done. If you want to illustrate by an example, okay guys, let's say you are given this example, ln of e to the power 2x. Okay, they ask you to find dy over dx. So it's going to give you e, sorry guys, e to the power 2x. You derive this over e to the power 2x again. So we all know how to differentiate that one. You take the 2x down, you derive it, okay? Then multiply by e to the power 2x again, okay? Over e to the power 2x. So we can see that this can cancel each other, okay? And we remain with what is remaining here? 2. Yeah. The derivative of 2x is 2. Okay guys, now let's talk about the derivative of a trigonometric function. So the trigonometric function, we have cos of x, f of x. If you wanna differentiate this, okay, you start with a minus. Whenever you see cos of f of x, you start with a minus, okay, don't forget this. Then you differentiate f of x, you multiply by sine of f of x. For an example, cos of 4x, you derive this, is going to give you 4x, you derive, don't forget the minus, Okay, sine of 4x, and finally you get minus 4 sine of 4x. Another example is for sine. When we are given sine of f of x, they ask you to differentiate this. For sine, don't start with a minus because there's no minus here. Straight, you take f of x, you derive it, then you multiply by cos, changes, of f of x. Example, sine of 2x, they ask you to derive this. It's going to give you 2x, derive, you change to cos of 2x, and finally you have 2 cos of 2x. So guys, from these two trigonometric function in cos and sine, you can find any other derivative of a trigonometric function because we have tangent, cotangent, cosecant, and all that you know. So this is all. Okay guys, I hope you enjoyed this video. In the next video, we'll try to explain the hyperbolic functions as well. And we'll provide as well a formula sheet for the remaining function that we couldn't show you today. But don't worry, everything will be okay. It was your tutor, Alex. This was just a revision of everything that you've seen in Maths 1 because you need to know them in order for you to take now Maths 2, okay? So, but another video is coming, okay? Now we're going to talk about the hyperbolic functions, the inverse trigonometric functions, inverse hyperbolic functions,